So we start the panel discussion of the session 3. So we have two speakers. Okay, so I asked one question each, actually. So the first question is, so you are doing such a many presentation in your YouTube. So,
yes.
So do you think that when people watch your YouTube, do they really understand?
No. But this is very interesting that you all know that general public, they have really lots of interest in black holes and time travel. But what I feel like is that they don't actually want it to understand, but they want to hear about this wonder and the miraculous thing. And I think even for quantum physics, most people, they have this...
Then it sounds like they are satisfied, even though they are not understanding.
I think that's a different satisfaction. When I deliver my talk to general public, I always try to persuade them that this is really interesting. But whether or not they understand completely, it's a different problem. So I think what we physicists need to try to convey to general public is to show them that this is very important and this is very interesting, and it's up to them if they understand or not. And it's very difficult to make them understand even very simple physics concept.
Okay, so it sounds like we are doing good in the sense that they can get interest in.
Yes.
Okay. Okay. So one question to Fisar is so you showed us such kind of education program. So I think that not only the general public but the engineers in other fields who are interested, and also there are somebody not in engineers but some kind of economics and so on, wanting to understand the quantum computer at least. So do you think that educational materials, when they watch, you also have a lot of YouTube videos on that, so do you think that it's really helpful them to understand the quantum computer? I think that should be true. And how about the quantum physics also?
So thank you so much. Very interesting question. So in general, we have noticed broadly two kinds of audience that are very interested in quantum. One is who are very interested in the science behind it, on how it works, the depth of each and every operation and all those processes. And the other one is usually on the working professional side is just, I want to make it work, right? And for those two communities, that's the reason why if you see in the program, it does not has a very specific focus on going super deep into theory or super deep into code. It has a mix of both. And that's where we are trying to make sure that it's helpful for both the audiences. And so if you see in the program, we have resources on quantum information science side. You have 2 complete courses on that. But at the same time, we have have a set of track that is what we call as the quantum computational scientist track, which may not have super depth information about quantum information, but they have the skill sets that are necessary to have a quantum workflow deployed on a quantum system. And that's where you'll also see that there's a lot of hands-on aspect to it, where we have introductions both theoretically, but also introductions on a more abstract way, explaining using code. So far it has been helpful to both communities, but I think if we are trying to broadly empower our workforce, we need to also think about these two personas and how we can make sure that we frictionlessly have them aware about quantum computing and join the workforce and join the community and make contributions in this space.
Yeah. So I think we agree that one of the reasons the quantum mechanics is so difficult to general public is, all of them, including actually me, have no chance when you're a child to play with quantum mechanics. There's no chance to experience quantum mechanics. So sometimes I'm thinking that the small qubit quantum computers, real or simulated one, may give them a chance to play with and have some ideas about some experience of the quantum, not only the quantum computer, but also some concepts of the quantum physics. So do you have some comments on that? You, both of you.
Yeah, that's exactly where we started off Qiskit with. When we started off Qiskit, actually, for the folks who have been around for a long time, we had these things called Qiskit Air, Ignis, and basically the elements of Earth. And it focused a lot on actually giving that first hands-on experience to people, making sure that there's these modules that have these applications implemented. Now, they were not scalable, and I don't think they were much realistic, but in some sense it gave people at least that experience of just running that experiment which they had seen on textbooks and simulated on a quantum system, even if they did not have access to it. And speaking on the access part, we also tried to make sure that we could give that. Previously, we had a lot more generous access program where people could just sign up and get access to our systems. Now we still have 10 minutes of access. So I agree. I think it's also a very important aspect of staying engaged and moving forward is also having that element of engaging with the technology directly. So yeah.
Okay, thank you.
Wow, I don't know, that must be very difficult. Your question makes me think of this concept of a quantum toy, quantum bear and quantum doll. Is it possible? I don't think so.
My experience is that when my kids doing computer games, their aim is just getting more points.
Yes, sure.
Yeah, as long as it's helpful for them to getting more points, they can do anything in the computer game.
But I think
so they can accept any rules, so it can be.
I think some physically touchable and tangible physical toy must be very difficult, but what IBM is doing can be used for...
So you're more physical toy, you're thinking about?
That can be very interesting in subject, but I cannot imagine. Any idea about quantum toy?
Yeah, quantum
toy for babies.
That would be interesting. I'm just imagining how it would look like. Yeah, that would be very interesting product. But speaking on digital games, I think our community came up with some interesting game. I know there's a port of Minecraft-like. It's called Qiskit Blocks. It's basically a Minecraft version where the player basically has gates, and it's a escape room situation. You're locked in a dungeon, and there's a state that's given, and you have gates. You basically have to make that state using the gates, and the door does not open until you get the required state. So yeah, that's interesting, and having more gamified aspects is definitely helpful.
Any question or comments from audience? Okay, Jenny.
Thanks. I mean, really interesting and really different talks. I mean, you're both reaching enormous numbers of people, but one, you're a giant multinational company, and then, Professor, you seem to be doing this single-handedly or with a team. I'm just really curious if you can speak to the kind of resources behind the reach that you've achieved, like how many people are involved. And Professor, I don't know if you have a team helping you with your YouTube channel. You could tell us a bit about that.
About my YouTube channel, I once prepared in some another YouTube channel, and then the company running this YouTube channel contacted me, and then we opened this my YouTube channel together. So there is a team composed of like 4 or 5 people, and then usually they just picked the subject what they believe that the Korean public will like it, and they suggest it. And sometimes what they suggest to me is very childish and very strange subject. But then, even that, I try to answer all those small questions. Like, for example, what can it be? Is the Spider-Man is possible? Or all different things. Ant-Man, does it violate physical law? All the questions the company, this writer, gives me, and then I prepared it, and then I filmed it, and then there are several cameramen, and then everything else, all the practical things, is handled by that team. I just prepare what I'm going to talk in this channel.
Thank you. Okay, yeah, please.
Yeah, what do you think about the future of the superconductor-based quantum computer? For example, if you are trying to make the 10,000 qubit, it requires a huge dilution refrigerator, and there is a large coaxial cables. So I believe it's not, I don't know if it's probable or not. And also there's some cost issues. Some people say it costs about $100,000 per qubit nowadays. For if there's 10,000 qubits, it costs $1 billion, I guess. So who buy it? So what do you think about that? Yeah.
That's an interesting question. I think IBM feels superconducting qubits are the way to go. We have a very well-defined roadmap that's there, that's explaining how we are going to reach that milestone, broken down in each and every year and broken down right to the detail of the stack. And I agree, this was one of the learnings that were there, is how do you make a 10,000 qubit chip? And the answer is not going monolithic, but just dividing it into multiple chips and having them connected. So if you see at our roadmap, and I did not really touch much deeper into it, we are basically going up with these technologies where we are building these couplers that can interface between multiple chips, and that's the way to basically go forward towards bigger systems, not just connecting across chips, but connecting across different fridges. Cost is also an interesting argument, but I would argue back that superconducting qubits are actually much, much, much cheaper than other technologies. If you see the operating cost models and business models across different technologies, IBM's is by far one of the most least expensive ones. So I would say that this technology has a lot of merits, and this technology is something that can go forward down the line, and IBM is committed to holding on to this.
Okay, so we are on time now. So yeah, so we close the panel discussion of session 3 and have a coffee break of 30 minutes. Yeah, thank you very much.